We are the new section on functions of several variables. Okay, so before I start that new section, let us do another example. Solve say y double dash plus 3y dash plus 2y equals 2y equals e to the minus 6. E to the minus 6. Now, what happens? The auxiliary equation, so we have to get the homogeneous one. First, we have to find the complementary function. So we have to first solve this equal to 0. So complementary function yc, complementary function, we need to find yc. Okay, complementary function yc. For that, we need to solve y double dash plus 3y dash plus 2y equal to 0. So what is the auxiliary equation? Auxiliary equation is, we know double dash becomes m squared plus 3m plus y dash becomes m, y becomes 1 equal to 0. These factors quickly, m, two factors are 2 and 1 to get 3 and all are pluses. So this is equal to 0. Factor it quickly. Now, then we have m plus 1 equal to 0 or m plus 2 equal to 0. Therefore, m is equal to minus 1 or m is equal to minus 2. So how do you find the complementary function is that? Then we need the general solution of this. So we can, roots of the auxiliary equation are these. Okay, now we want to find the complementary function. So therefore, what is yc? Therefore, yc is equal to, yes, c1 e to the minus x plus c2 e to the minus 2x. That is the complementary function. After that, we need to find a particular solution. Complementary function is found. Particular solution is a solution of this equation, non-homogeneous one. Okay? This is the homogeneous solution of the homogeneous part is the complementary function. Now for yp, particular solution. See, particular solution. To find the particular solution, we have to write this equation in the form. Let us write it using the capital D notation. What is y double dash? Y double dash is d2y plus 3y dash is dy. D is d over dx plus 2y equals e to the minus x. That is the given equation in capital D operator, using D operator. Now this factors into d squared plus 3d plus 2y equal to e to the minus x. So a particular solution is yp is equal to 1 over d squared plus 3d plus 2 e to the minus x. E to the minus 6. Now to find this, we can use the formula. We shall use the formula to find the particular solution. We shall use the formula 1 over fd function of d, which is d squared plus 3d plus 2 here. If we have this times e to the alpha x, we know the answer is 1 over f alpha e to the alpha x. All you have to do is substitute alpha for capital D, and this can be applied only when f alpha is not equal to 0. If f alpha is not equal to 0, we can do this. Now, actually, I'm starting with an example where we can do that. You all know how to do this problem. Now you put -1 into this. What do you get? We know it is not going to be 0 because yeah, sorry. What will happen? Yes, this can be applied. So what is f alpha? Try to apply it for this problem. What is fd? Fd is equal to d squared plus 3d plus 2. 3d plus 2. Yes. I have given it straight away, in fact. What will what is alpha here? Alpha here is -1. F of alpha, f of -1. -1 squared plus 1. -1 minus 3 plus 2. Now what will happen? That is equal to 0. If this is not equal to 0, we just substitute alpha for d. That is what we have to do here now. We just substitute alpha. But if f alpha is equal to 0, this fails. You cannot apply this. Okay? So we cannot apply. We cannot apply 1 over fd e to the alpha x equals 1 over f alpha e to the alpha x. We cannot apply. We cannot apply this to find the particular solution. So how do we do it in such cases? If f alpha is equal to 0, if that becomes 0, we use a similar, more advanced equation than this to find yp. This is the formula. I will straight away give you the formula. You can verify that. This 1 over, we derived this one. Okay, I'm giving you the formula to find the particular solution when f alpha becomes 0. What we do is we apply this more general formula. 1 over fd e to the alpha x times u. U is a function of x. U is a function of x. X is the hidden variable, y dash is dy over dx. U is a function of x. If you have something like this, now 1 over fd is what we want to find, but that is if e to the alpha is x is there, and if f alpha is not equal to 0, we can do it. But otherwise, we apply this formula, 1 over f of d e to the alpha x times u equals e to the alpha x 1 over f d plus alpha u. Okay, we can verify this by applying f of d to both sides, and there's a little bit work there, but I will give you the formula. Okay, so rarely I do that, but since we are pressed for time, we shall take this as a fact. Okay. Now, even when we are not applying alpha, no, we are applying e to the alpha x times 1 over f of d plus alpha u. Now go to this one, okay? Now we can apply, so we cannot apply this formula, but we can apply, we can apply this formula. This when F alpha is, we are not finding here, this side is not F alpha, no? Not 1 over F alpha like in the formula used earlier. Even when F alpha is equal to 0. But so what do we do? I need to find YP. I need to find YP. YP is this. So now write YP equals YP is equal to 1 over F of D. D squared plus 3D plus 2 e to the minus x. This is what I want to find. I cannot put D equals minus 1 and find the solution, particular solution, because if I do that, I get F alpha. I get F alpha is equal to, alpha is minus 1, e to the minus 6. I would get that F alpha equals 0. So now apply this formula. What do we do? This says, so I take, you need e to the alpha x times, you know where u is a function of x. I will consider this as this times 1. 1 is a function of anything, no? Times 1. Apply the formula. See whether you can apply it. How do you apply it? This is 1 over fd e to the alpha x. Alpha is minus 1, alpha x, u is 1. When you apply it, you take e to the alpha x out, e to the minus x times 1 over, what is this one? You have to have f of d plus alpha. So d replaced by d plus alpha in the expression. Now alpha is minus 1. Alpha is minus 1. So d plus alpha is the same as d minus 1. So you have to write in here, instead of d plus alpha, meaning d minus 1. So write d minus 1 here. D minus 1 squared plus 3 times d minus 1 plus 2. Sorry. Replace. And here we have 1. U is 1. So this is equal to e to the alpha is taken out and replace d by d plus alpha u. So this is what you have. Simplify this to see what happens. E to the minus x here, 1 over square this. D squared minus 2d plus 1. 2d plus 1. Here we get plus 3d minus 3 plus 2 of 1. Now minus 2d plus 3d. Doing it right now? Be careful. Huh? Plus 1 plus 2 minus 3. Those 3 terms cancel. D squared minus 3d. How do you do it? D squared minus, so this is equal to e to the minus x that is equal to e to the minus x 1 over d squared plus d. D squared plus d, okay, of 1. Now you can factor this out. How do you find this one? 1 over d is like integration, because d is like D is differentiation. So e to the minus x, that will stay there. Factor this out. 1 over d. If we have just 1 over d1, that is just to integrate 1. But we have d times here, d plus 1. D times d plus 1. How do you do this? This is equal to e to the minus x. We have to make this 1 over, write it as 1 over d times 1 over, write this as 1 plus d. 1 plus d, 1. 1 over d, we know, we can just integrate. 1 over d is integration. So, but before that we have 1 over 1 plus d also. There is no way to substitute anything and do it. Here, we have to use a formula that we learned under infinite series last semester. That is 1 over 1 minus x. If you have 1 over 1 minus x, this is equal to 1 plus x squared plus ... infinite series. This is valid only for absolute x less than 1. 1 over 1 minus x. So here we have 1 plus d. So instead of x, we write 1 over 1 plus d. 1 over 1 plus d equals, so instead of x, put minus 1. That's a formal thing. This is for real numbers. We can apply that for operators also to find particular solutions. 1 over 1 plus d. So x, instead of x, we have minus d. So this is 1 minus d plus d squared. That's enough, okay? Because this is 1. If you get the derivative, of 1, it becomes even, this one would make that 0. Minus d cubed, we don't have to write the rest. Plus ... Use this coming from this in here. So, that is equal to e to the minus x 1 over d. What do we have there? 1 minus d plus d squared minus ... of 1. Now do this part. D is the derivative. 1 times 1 is 1. So e to the minus x, 1 over d, e to the minus x, 1 over d. This whole thing is just 1. Because d of 1 is 0. D of 1 is 0. The derivative of a constant is 0. So if you take d2 of 1 is also derivative of 1 is 0. If you take the derivative of 0, 0. All the rest applied to 1 becomes 0. So you only get 1. As I told you earlier, 1 over d1. 1 over d is d over dx. D over dx is d. What is 1 over d? Then 1 over d is equal to integration, the inverse operator. Inverse of derivative is integral dx. So here, what we have is, you understand it. D is taking the derivative. D applied to 1 over d is, they cancel each other. No? So you get the integral. So 1 over d is the integral. So here e to the minus x integral 1 dx. That is equal to x. That integral 1 dx is x. No? We don't need an arbitrary constant because we need only one solution. So we get the particular solution as x e to the minus x. x e to the, this is x, no? X e to the minus x. That is our yp. So yc we know, yc was what? C1 e to the minus x plus C2 e to the minus 2x. Now here, that is yc. Now from what we have done here, we know yp is equal to x e to the minus x. X e to the minus x. Therefore, the general solution of the given equation is y equals yc plus yp. C1 e to the minus x plus C2 e to the minus 2x plus x e to the minus x. Where C1 and C2 are arbitrary constants. That is one way of doing the particular solution when f alpha is equal to 0. Now I want to tell you something. To understand how to find the general solution of a given non-homogeneous equation with constant coefficients. So all our examples we did involved e to the alpha x type. So now having obtained the answer, I could have done it this way. Okay, so understand the method and application of that new formula for a 1 over f of b e to the alpha x times u. So there are two formulas. If this is there, then we can do f alpha e to the alpha x. If f alpha is not equal to 0. If f alpha is not equal to 0, we can use that formula. Otherwise, we consider it as this times a function of u. So you can have not only e to the alpha x, even in our e to the minus, if I had something like x cubed e to the minus x, x cubed e to the minus x, I could still use this formula. U is x cubed. So this is x cubed there. Now look at what happened. Since it's a d squared equation with a constant there, what is the general solution particular solution we got? X e to the minus 6. X e to the minus 6. So if you had x there, see, if I had x there, e to the minus x times x, I earlier said x cubed, let us just take x, then what would happen? This would be x there. So you would get 1 here, x dx is if this is x, you get x, dx is 1. All the rest becomes 0. So you see that when you have a function of x times some x term, like just a power of x, like x squared, x cubed, whatever here, what we get is, if it is 1, you get x e to the minus 6, x e to the alpha. If it is x, you would get, if that is x, you would get x squared type thing. So if it is x cubed, we have to integrate this now. So you get x, when you integrate, you get x squared term there. So not sure whether you got what I said there, but to explain that further, how to find a particular solution, particular solution by guesswork. Solution, you just guess a solution. Guess the solution. So, guess the solution. We can, the equation given y double dash plus 3y plus 2y, 3y dash plus e to the minus x. You guess the solution. If f alpha is not equal to 0, we can quickly do it. So you don't have to guess and do. The other case, we did another formula to apply. You can stick to that. Or you can just guess the solution. Let guess y equals say e to the y equals x a x plus b e to the minus x. We got x e to the, remember, even here for this one, ax would be enough. But ax plus b, if ex e to the minus x is there, solution will look like this. Ax. So if it is 1 there, we put a linear one. If it is x there, we put a quadratic. Ax plus b, where a and b are constants. Substitute. Y dash is equal to ax plus b. What is this is going to be? We have to use the product rule. Derivative of this is a e to the minus x plus ax plus b e to the minus x times minus 1, derivative of this. So we have e to the minus x can be factored out. E to the minus x factored out. You have a from this one, you have minus b. A minus b e to the minus x. Then we have minus ax. That is what you can put for y dash. Then find y double dash, again product rule, and then substitute and sub into this equation. Sub into 1. Find, when you sub into 1 and do it, you will get, and then you get a equation from which you can find a and b both. When you do that, you will get, what was the answer we get? X e to the minus x. No, we get a equals sub into 1. That will give you a is equal to 1 and b is equal to 0. So if a is equal to 1 and b is equal to 0, so this is yp, particular solution. So therefore yp, particular solution, is x e to the minus x. So guessing that would be a little bit work. That is why I just showed you the method. Guess method. It doesn't matter if somebody tells you the solution of this, then that is a particular solution. So if you say, if you wanted to verify that this is a solution of this, what would you do? You substitute it into this equation. Okay. So from that also, guesswork also, you can find a particular solution. One last example. So I didn't complete it. Just told you I have given you a sure shot method. No? So, but this guessing a solution method is also can also be used. Next example. Solve this problem. D squared plus 1 y is equal to x squared take this little equation. Now I'm using the this equation after multiplication would become y double dash plus y equals x squared. So you should be comfortable with any notation that is used for differential equations. This is the same as d squared y over dx squared plus y equals x squared also. Any form. When it is non-homogeneous, this form is good because we need to get the particular solution. To get the particular solution, we have to write it this way anyway. And if we are not guessing, if you are guessing, any form is okay. But YP, 1 over f of d method, you need this. Now, what is the what is YC? To find YC, we have to solve complementary YC. First find YC, put this side 0, d squared plus 1, y equal to 0. From that auxiliary equation, what is the auxiliary equation? What is the auxiliary equation for this homogeneous differential equation? Instead of capital D, we put M. So what do we get? And for Y, we put 1. So you don't have to write it in this form or this form. This form, okay, y double dash, m squared, y 1. But if it is written this way, just replace d by m. M squared plus 1 equal to 0. Auxiliary equation for this is this. Now from that you get m squared is minus 1. Therefore, m is equal to plus or minus I. Square root of minus 1. No? M is equal to square root of minus 1, which is plus or minus I. This is like alpha plus I beta. Alpha is equal to 0. Beta is equal to plus 1 for plus I, minus 1 for minus I. Okay. So alpha plus or minus I beta. So then in that case, beta is equal to 1. So when roots are like this, what is the complementary function? YC C1 e to the alpha x, e to the 0x, e to the 0x, then cos beta x, meaning cos x plus C1. There. Sorry. E to the alpha x, C1. Let us write it. M is equal to plus or minus I. So what is YC? YC is equal to e to the alpha x. Solution, let me write here since I made a mistake there. E to the alpha x, C1 cos beta x plus C2 sin beta x. So YC is equal to e to the 0x, meaning 1. E to the alpha is 0. No? Compare with this. If these are the roots of the auxiliary equation, this is the general solution of the homogeneous equation. YC 0x, C1 cos x, alpha beta is 1, cos beta x plus C2 sin beta x, meaning sin x. So this is equal to 1. So let us not waste. So that is not there. C1 cos x plus C2 sin x. And now I need a YP for this. YP. How do I find YP? YP is not this. This. There is no YP for this now. You don't use that particular solution. We have the general solution for this complementary function. YP is 1 over d squared plus 1 x squared. 1 over, so YP, write the equation d squared plus 1. We have the capital D operator already in. So yp is equal to 1 over d squared plus 1 x squared. It's not e to the, just a polynomial, quadratic. I have taken a very simple quadratic, but you can have any quadratic there, or any polynomial for that matter. This method works. This is equal to now 1 plus d squared x squared. How do I do this? We use that formula, 1 over 1 minus x. So write this as 1 over 1 plus d squared. You can, operators switch now, they are the same. D squared plus 1 over 1 minus x is 1 plus x squared plus ... Valid for absolute x less than 1. Real infinite series. This is a geometric series. 1 plus x squared and so on. Okay, so what is 1 over 1 plus d squared? Can somebody say? We said we can use this formula for the operator also. So what is x? In here, to get this, x is minus d squared. X is, replace x by minus d squared. Minus d squared becomes 1 plus d squared. What is the series? 1 plus these not plus 1 minus x is minus d squared. 1 minus d squared plus d to the power 4 minus ... We don't care because this is x squared. No? When you go to d to the power 4, okay, which is the power 4, derivative becomes 0. Now substitute this into substitute. So I'll do it here. This is equal to, using this, we can straight away write 1 plus minus d squared plus d to the power 4 minus ... x squared. That is equal to, when you multiply this by this, you get x squared minus d squared x squared. D to the 4x squared is 0. Because if you take the derivative of x squared 3 times, it becomes 0. The other, d to the 4x squared minus that. I'll write it like that. Now, first one, x squared, d squared x squared. Meaning, take the derivative of x squared twice. What is dx squared? Derivative of x squared is 2x. So d squared x squared is derivative of this again. That is just 2. This is equal to minus 2. Here, d to the power 3 x squared is 0. Derivative of 2 is 0. So this is 0 and all these are zeros. So you get x squared minus 2 as the particular solution. Okay, x squared minus 2 as the particular solution. So, x squared, d squared. Okay, everything is okay. Yes. Now, what do we have? Yp we have, therefore, the general solution of the given equation, y equals complementary function c1 cos x plus c2 sin x plus yp. Yp is, here, yp is x squared minus 2. That is the general solution where C1 and C2 are arbitrary constants. Where C1 and C2 are arbitrary constants. This is YC. This is a particular solution of the whole. Okay. So these are the type of questions that you will get for the exam also. I want to, before I start the next section, want to tell you a little bit about how the evaluation is done. Now, we have given you tutorial number 5. Last time I told you I give the assignment on Thursday, that is tomorrow. Okay, assignment. So we take from tudes. We give 20% for tudes. Assignments. There are 2. The first one will be given tomorrow. Next one will be given later. First one will be on linear algebra part. So that is 2 assignments also, 20%. Then there is the end semester examination. End semester examination. So this is 40, 60%. Okay. So that is how the 100 marks are divided. When I give the assignment tomorrow 9 a.m. assignment will be uploaded. Linear algebra. Just you can use your notes. You can look at textbooks, whatever. It's like an open book examination. Okay. But what you write, you must write what you understand. Okay. Don't copy. It's an exam. No? So I have to trust you for that. 9 a.m. Tomorrow, Thursday, it's uploaded. You have to submit it before 12 noon on Friday. Okay, it doesn't take more than 2 hours to do the exam. I could have just said submit it in 2 hours. Work is basically 2 hours work. So you are doing with other things, no? So that is why that much of time is given. Okay, and problems are very similar to the ones we have done, covering the entire linear algebra section. That will help you do the end semester exam also. Okay. If there are any questions, you can ask now regarding that. So, differential equations part and what we are starting today, that after finishing that, I will give you a second assignment that would be good practice for end semester exam also. We have been asked to finish everything by 28. So, we have missed 3 sessions. I would like to have a extra session, maybe 4 to 6 is a time where there is no power cut. No, if you are free, we will talk about it and do it first. Get it done. Get this work done. Okay, and next Monday. We shall try to have an additional session, okay, to cover the syllabus. Although I'm no longer attached to the faculty, I will be setting the examination and marking and everything. I will finish the 2 courses I have started. Doing it for free, okay? Yes, something I started now, so I have to finish it. Yes, enjoyed teaching students at Rajitha very much. Okay, so shall we start the new section? Only thing is, if you can talk a little bit, that would make my life a little more interesting when teaching. Okay, when you are just, first years are good. Don't ask them not to answer, okay? They are good. They use the chat a lot and unmute and ask questions. Uh, you can, when a lecturer asks a question, please try to answer. I mean, for me, I don't care whether you answer it correctly or give an incorrect answer. Who cares? That allows me to uh, adjust my pace of teaching so that you can understand. So last section for the course, it is functions. So we have linear algebra, differential equations. Now we are going to do functions of several variables. But we are doing actually functions of two variables that can be extended to several variables also. Functions of several variables. So far, variables. So far, in 1303 and 1307, we dealt with functions of a single variable, f of x. Here, we are going to do the same for functions of more than one variable. What I mean by saying we are going to do the same, we are going to find derivatives, we are going to find integrals. Okay, derivatives are called partial derivatives when it comes to several variables. Partial derivatives. Integrals are, if it is two variable, double integrals. Three variables, they are triple integrals. Okay, so we are going to cover that. Before we do that, we have to understand. Wait. My table is a mess, so I kept. Yes. Something, but cannot find it. Yes. ඔගොල්ලෝ මොනවාක්වත් ඇහුවේ නෑ අර මේ assignment එක ගැනවත් මොනවාක්වත් අහන්නේ නෑ නේද? ඔව් වෙන්නේ ගිහිල්ලා. Functions of several variables. So before we do that, we need to understand the three-dimensional space, which we did for vectors last semester. Okay. Let me start by if you take a function like y equals x squared, f of x equals x squared. Okay. Graph of this function lies in the xy plane. XY plane, we know graph of this function is the same as graph of this equation. Then we plot that on the XY plane. We know we get a parabola like this. That is a function of a single variable case. Now we are going to move on to functions of several variables. That is very common. Like if you take the volume of a cylinder, it's a function of two variables. Volume of a cylinder. If this is R and this is H, volume V is equal to pi R squared H. Pi R squared H. Now, R is the radius, H is the height. For different cylinders, R and H are different. So this V depends on two variables, R and h. So v is a function of two variables. V is a function of r and h. So similarly, we can talk about something like fx comma y equals x squared plus y squared. This is a function of two variables. Input and a pair. When you put one input for x, one real number. Here, you have to have a pair of real numbers. Pair of real numbers. For example, if f of x comma y equals x squared plus y squared is a function of two variables. Output is a real number. Input, a pair of real numbers. Can somebody tell me what f of 1, 2 is? What is f 1, 2? Earlier, just one number, now 1, 2, two numbers. Ordered pair. We don't put another parenthesis like that. We just write this. So, while identify input for x is 1, input for y is 2. So, 1 squared plus 2 squared, which is equal to 5. Now, yes. Now, look at next example. Take something like f of xy equals 2x plus 3y minus 2. What is f of 1, 2? There. What is f of 1, 2 for this function? Why do I take 1, 2? Let us say 2, 3. F of 2, 3. What is it? Function is a rule that assigns to every member of a set a unique member of another set. Here, x comma y, our input lies in the xy plane. There is an output. Earlier, input lies on the x-axis, output we sketched on the y-axis. Only one input, one real number. Here, this is an ordered pair. I'm going to come to that. Pair of numbers. If you want the rule applied to this pair of numbers, rule applied to this pair of numbers is the output twice the first input plus 3 times the second input minus 2. Can you tell me the answer to this? Somebody? අපි නම්බරයක් කියමුනේ. Yes. 11. Okay. 4 plus, so 2 times 2 plus 3 times 3, y is 3, no? Minus 2. So 4 plus 9, 13, minus 2 is 11. What is f of 3, 2? F of 3, 2. Now, here, first one is 6. Plus, second one is also 6. Minus 2. That is 10. So, here, x comma y is considered as an ordered pair. Order in which we write things are important. Okay? So, x comma y, this is a f of x comma y. When we say that x comma y is a x comma y is an ordered pair. Order matters. Ordered. Inputs are ordered pairs. Ordered in, when you write fx comma y, x comma y is an ordered pair. So, input is an ordered pair. Pair of real numbers. Order is important because if you change the order, number answers are different. So, function of several variables or two variables here is a rule that assigns to every ordered pair a unique real number. See, input-output relationship is a function. No? Now you input ordered pairs. Your output is a real number. So real valued, so we are considering values of the function are real. So we say real valued. Values are real valued functions of two variables. Two variables meaning ordered pairs are real valued functions of two variables. What are the variables? X and y. Now, this y is an independent variable. Here, this y, if you take f of x equals y squared, when you write y equals x squared, y depends on x. X is the independent variable, input variable. Y is the output variable. Now, x and y are both input variables, function of two variables. Two real numbers are needed. An ordered pair or two variables are needed. So we have denoted them by x and y. So output should be another number. See? Earlier, input, one real number as input gave you one output. Use this XY plane. Now what happens? Input itself requires two numbers, x and y. Output, input x comma y. Input x comma y. Let Z be the output. So we now, earlier we had y equals x squared when f of xy is this. Now when f of xy is something like this or this, any function of two variables, we need another letter to denote the output. Z equals fx comma y. Z equals fx comma y. Y is not f of x anymore. Y is an input variable. Earlier y was a dependent variable. Here y is an independent variable. Independently of the output we input. We first do the input to get the output. No, he said this is the dependent variable. Okay, so how do we sketch? How do you visualize functions of two variables? Functions of a single variable, we do it in the xy plane because you need one real number for input and another for the output. Now you need two real numbers for the input and one real number for output. We said we are doing real valued functions of two variables now. So he said output must be a real number. So those are the functions that we are discussing here. Now, how do you visualize the graph of such a function? So what are the what do we mean by the graph of a function? Input output pairs. For a given x, you find y and plot x comma y dot. For all real numbers, there is a unique output, input comma output. Now here, if you try to do input comma output, how many variables are there? Two for input and one for output. So we have to move to, we cannot do it in the xy plane. In the xy plane, we can try to plot the domain of the function. Domain is the same as before. The form with the largest set on which the formula makes sense. What is the domain of this function? All real pairs. Any real number for x and any real number for y is okay. So domain of this function is all real pairs. Here, what is the domain? Domain of this function. Domain is equal to R the set of all real numbers. What is the domain of this function? Domain is, we write r squared. R squared. Meaning, r squared, what is the meaning of r squared? Some people write r squared as r, not dot, cross r. Meaning ordered pairs of real numbers, r cross r. One real number for first input, another real number, or same number can be used also. Another for the second input. Domain is r squared. What is the domain of this one? Domain of this function is also any real number. Any real number would give you a real output. So domain of this one is also r squared. Domain is equal to r squared. Now, what is the domain of this function? F of xy. Suppose we have f of xy equals 1 over x squared plus y squared. What is the domain? Domain of this function, 1 over x squared plus y squared. You know, when you find domains, if there is 1 over, this should not be 0. No? So this formula is bad when x squared plus y squared is equal to 0. Domain is given by, one way to say it is x squared plus y squared not equal to 0. But when is x squared plus y squared equal to 0? Bad when, other words, bad when x squared plus y squared equal to 0. So domain should be this, but we can visualize it better if you solve this. Only one equation, two variables. But we know x squared is always, x is a real number, greater than 0. Y squared, a real number, non-negative. If you add two non-negative numbers and get answer 0, this is the same as, equivalent to, this is equivalent to only one solution. What is the solution? Can somebody tell me? Equivalent to LENT. If x squared plus y squared is equal to 0, both x and y, both must be equal to 0. If one is non-zero, when you square, it becomes positive. Positive plus a non-negative is not 0. So if x squared plus y squared is equal to 0, equivalent to x is equal to 0 and not O. X is equal to 0 and y is equal to 0. Understand? Another way to say that is x squared, put this to the other side, it will become minus y squared. If x squared equals minus y squared, we know if y is non-zero, x squared would be negative. Y squared is greater than or equal to 0. If y is non-zero, this is negative. If x squared is negative, x is not real. So y has to be 0. If y is equal to 0, x squared is 0. Therefore, x has to be 0. Or easier to see this way also, x squared, x and y are real. X, comma, y, without parenthesis, they are real numbers. So real numbers, x squared is greater than or equal to 0. Y squared is also greater than or equal to 0. So if you add and get 0, both must be zeros. So x is equal to 0 and y is equal to 0. So what is the meaning of this? What is the meaning of this? Domain is given by x squared plus y squared not equal to 0. X squared plus domain equal given by x squared plus y squared not equal to 0. Same as saying x not equal to 0 and y not equal to 0. Meaning x comma y not equal to 0 comma 0. Because this gives, if this is 0, we get x0 and y0. That is the only time when this can be 0. So x is 0 and y is 0. So domain is given by x comma y not equal to 0 comma 0. So domain is given by x comma y not equal to 0 comma. It's like 1 over x. Domain is given by x not equal to 0. But here x comma y not equal to 0 comma 0. D of f, domain of f is equal to, you can say, R2, entire plane x comma y minus the point 0 comma 0. Geometrically, the domain x-axis, to understand the domain you need two numbers, no? X comma y with a hole at the origin. This is the domain of this function. So to explain the domain of a function of two variables, you need the xy plane. So for the range, you need another variable. We denoted it by z. So this is the domain. Now, this example. So there is those things which we did for one variables now can be extended to functions of more than one variable. Next example. Let f of xy be. Let f of xy be square root of 1 minus x squared minus y squared. Tell me the domain of this function. For one variable, finding domains, we said if you have 1 over something, that this should not be 0. If you have square root of something, inside must be greater than or equal to 0. Otherwise, you won't get a real number. No? Can somebody tell me the domain? Describe the domain of this function. Function of two variables. What is f of 2 comma 1? F of 2 comma 1. What do you get? Square root of, yes. F of 2 comma minus 1 is going to be square root of minus 4, no? Not real. So that cannot be, the 2 comma 1 cannot be a point in the domain. Not real. What is the domain of this function? Domain of f. Domain is given by, yes, there is a square root. Inside of the square root must not be, otherwise it won't make sense as a real number. Like here. Some numbers are not in the domain. Some points rather. Domain is given by inside the square root 1 minus x squared plus x squared minus y squared. 1 minus x squared minus y squared greater than or equal to 0. Same rules apply. 1 over something, bottom should not be 0. If there is a denominator, denominator should not be 0. If there is a square root, inside must be greater than or equal to 0. Otherwise, you won't get a real output. So x squared, 1 minus x squared minus y squared. Now, what is that? Try to understand this. Take x squared 1 bigger than or equal to x squared plus y squared. No? If you throw x squared and minus x squared minus y squared to the other side, i.e. that is the same as saying, better to see it this way, x squared plus y squared less than or equal to 1. Now, plot the domain of the function. We need the xy plane. Earlier, one variable. For the domain, we needed only one real number. One axis to represent the domain. Now, you need the entire xy plane to, because inputs are pairs. Pairs live in the xy plane. So, x squared plus y squared less than or equal to 1. So, what is the domain of the function? D of f, domain of f, we denote by df, say, domain of f is x comma y. In R2, I'm just trying to make you little more mature mathematically to understand this notation. What is the meaning of this? Ordered pairs or points in the R2 is the same as xy plane. R2, R squared. You should say R2, R3. R squared, R cubed, R2. X comma y in R squared, R2, such that x squared plus y squared less than or equal to 1. We know x squared plus y squared, square root is the distance from the origin in the xy plane. Let us plot this. You learn circles. Draw the circle centered at the origin with radius 1, 0. X squared plus y squared less than or equal to 1 is the same as the points in this shaded region. I have plotted that shaded region. We did complex numbers also. No, this is mod z equals to 1. Less than is inside. Less than, if I had equal to 1, we know it is a unit circle. Did the circles also earlier? So this is the shaded region. Shaded region is the domain of this function. What is the function? Square 1 minus square root. So square root 1 minus x squared minus y squared. So just to give you an idea about the domain of functions of more than one variable. So how do you plot the graphs of these functions? How do we plot their graphs? Okay, take the first one. X squared plus y squared. To plot the graph, the graph of f of graph of the function graph of the function f, two variables, let us write function f of y, x, y, is the graph of the equation. What is the graph of the function f of x or f when it is one variable? It is the graph of the equation y equals x squared. Input, output. Input, output pairs. Output is denoted by y, input by x. Now, if it is a function of two variables, x comma y, input takes two real numbers. So we need two axes, x-axis and y-axis for the domain of the function. Is the graph of the equation Z equals f x y. What is this Z? So Z, graph of the equation Z equals f x y. So to sketch the graph of a function of two variables, we need three mutually perpendicular axes. Okay, understand this. Vectors under vectors, we did this. X-axis coming perpendicular to the plane y z, which is the plane of the paper. X-axis is coming towards, x-axis is perpendicular to. So we draw it like this. What is this angle? This is 90 degrees. This is also 90 degrees. This is also 90 degrees. Okay. When you visualize the three-dimensional space, like two-dimensional XY plane, three-dimensional X, Y, Z coordinate system. Okay. If the right-hand rule applies X to Y, if you curl your fingers from X to Y, curl your fingers from X to Y, Z is perpendicular to that plane, meaning thumb will represent the direction of the Z axis. Thumb, yes, XY. The same thing. If you go from Y to Z, X is the pointing in the direction of the thumb. So it's a right-handed system of coordinates. Right-handed system. So X, Y, Z like that. Z can be considered as the vertical axis. Not necessarily, but it's a right-handed system. So for our purposes, we consider this as the vertical axis. These two are horizontal axes in the plane. Both are horizontal. XY is the horizontal plane. Z is perpendicular to it. Z axis is perpendicular to it. This is the origin. To represent points here, we know x comma y comma z. We have done vectors, and so therefore three-dimensional space is familiar to you. So is the graph of the equation this Z equals f of xy in R3. Three-dimensional space. Three numbers are needed. For every pair of every point in the xy plane, which is a point in the domain of f, there would be a real output. So let us now understand equations of first. So let us do so this is an equation in R3. Z equals fxy. So let us try to understand graphs of equations. Graphs of equations. I have given you a tutorial problem to be submitted today, where I ask you to find partial derivatives of functions of two variables. That's I will tell you how to do it, and it will take only 5 minutes to do that problem. Okay? Today is the submission deadline. So you might say, I have taught you and I have given you other problems. You can, why only assign very few problems, only 3 problems. Third one it takes only 5 minutes, okay, after the lecture. You can do it. I will make you understand how to do it before the end of the day. It takes 5 minutes to explain. But let us try to get a feel for functions of 2 variables today. After that, we'll partial derivatives. Now there are 2 variables. If you want to find the partial derivative with respect to x, you consider y as a constant and do all the derivative. If you want the partial derivative with respect to y, keep x constant, treat x as a constant and get the derivative. So 2 variables are there. Okay, 2 variables are there. So you can take the derivative of the function with respect to one variable, keeping the other variable fixed. If I have fxy, if y is fixed or a constant, it's a function of x only. Say put y equals 5. Fx5 is a function of x. F5y, put a constant value for x. X is not there, then it's like 5. So it's a function of y only. So although there are 2 variables, you can make it, though it is a function of 2 variables, you can make it a function of a single variable by treating one of the 2 as a constant. Then it becomes a function of a single variable. We know how to find the derivatives of functions of single variable. I'll explain it again. I sometimes do that without actually giving you enough to understand. I say things. Advantage is that when now you are, so I didn't understand them, but then when we actually do it, you will understand. The graphs of equations. Let me draw a few graphs of equations. Okay, sketch the graph of the first one. I'm trying to explain it using examples. Example 1. Let us consider Z is equal to 3. Z equals 3. Graph of equations in R3. So there are 3. Z equals 3. Sketch the graph of this function. Sketch. Not function. Yeah, it's a function. Of course, it's a constant. Sketch the graph of this equation. I'm trying to graphs of equations in x, y, z. In R3. Three-dimensional space. Sketch the graph. This equation. So first draw, like for equations in x and y, you draw the xy plane. Now this is equations in x, y, z, but only z is there. So we always have x, y. Now z equals 3. Z equals 3, meaning on the z axis, go to the place 3. So if I take this point, what is the z coordinate? Z coordinate is 3. X and y can be anything. So what you do is, there is a plane. Draw the plane parallel to the xy plane, horizontal plane, through the origin. Now draw it through the point 3. Draw a line parallel to this. Draw a line parallel to this. This is Plane is an infinite thing. It's not only in the first octant, it goes to the other parts also. It's like XY plane, we know it's not only this part, entire plane. So just to indicate, to take an understanding of this, we shall draw a plane parallel to the XY plane through the point 3. If you take any point on that plane, if you take any point on the XY plane, Z is equal to 0. XY plane. XY plane, what is the equation? XY plane. Z is equal to 0 at every point of the XY plane. So we say that is the equation of the plane. Now Z equals 3 is a plane parallel to the XY axis. We have to lift this up by 3. If Z is minus 3, then we have to go in the other direction and draw. First equation. Second equation, x is equal to 3. How do you draw x is equal to 3? Z equals 3, horizontal plane. X equals 3. How do you sketch the graph? X, Y, Z. X equals 3. Go to, this is the origin, 0, 0, 0. X equals 3. Go to the place on the x-axis where 3 is located. What is this plane? YZ plane. On the YZ plane, x is equal to 0. X equals 0 is the YZ plane. YZ plane. So x equals 3 is pushing it forward. Translate it. Push it. Along the x-axis, 3 units. Draw a line parallel to Z-axis. Draw a line parallel to the Y-axis. And just shade this. That is the plane. It's a plane. Through the point 3, point whose x-coordinate is 3 on the x-axis. So if I have, so third one, plot the equation y equals 3. Y equals 3. What is the graph of this equation? Remember, YZ plane is the plane of the paper. Y equals x-axis. Yes, you did see it. Y equals 3. How do you plot it? Y equals 0 is this plane. XZ plane. So y equals 3. Push it forward along the Y direction by 3 units. So, Y is in play. Now, Y, how do you draw Y equals 3? You have to, here, X, you drew lines parallel to x-axis and lines parallel to y-axis and the z-axis. Y equals 3. You have to draw lines parallel to, best way, y equals 0 is xz plane. So draw lines parallel to z and x. This is the plane. Y equals 3. It is parallel to xz plane. So those are, I think I may have drawn them earlier too, when we did vectors. Then fourth example, fourth one. Okay. Now, so first three are just the most elementary equations, 39. Spend about 10 minutes on this. Third one, not third one, fourth one. Fourth one, plot sketch the graph of sketch the graph of the equation sketch the graph of the equation x plus 2y plus 3z equals 6. You all know graph of the equation in x, y and z. What kind of a thing is this? If you see ax plus by equals a constant, we know in the xy plane it is a straight line. Similarly, ax plus by plus cz, something similar to this. Ax plus by plus 3c3z equals plus d equal to 0. This is a linear equation in x, y and z. This is the general form. This is a linear equation. You did linear algebra also, no? Linear equation in x, y, in x, y and z. It is the graph is a plane. I'll just see. It is a plane. It's a plane. I sketched 3 planes earlier. Plane parallel to the xy plane, plane parallel to the yz plane, plane parallel to the xz plane. 3 planes. But now it's only z, x, y, just one. Now all 3 variables are there. Linear equation in x, y and z. I don't have to explain this. You all understand it as a linear equation. The graph is a plane. How do you plot it? To plot a plane, I need 3 non-collinear points. 3 points which are not on the same plane. Best way to draw this is to find places where it crosses the x-axis, y-axis and the z-axis. X, y, z. X-axis. On the x-axis, y is equal to 0 and z is equal to 0. If you take a point on the x-axis, only x-coordinate is there. Y and z are y. Y is a plane. Is this no? On the x-axis, see, you can think of it this way also. Tell me what is the equation of this xy plane. XY plane is z equals 0. This plane, that is y is equal to 0. XZ plane, y coordinate is 0. So this line is the common line of intersection of those 2 planes. So this line lies on this plane and this line lies on this plane also. So on this line, y coordinate is 0 and z coordinate is 0. That is how we understand on the x-axis y is 0 and z is 0. Now go here and put y 0 and z 0. Put put these in, let me call this equation 1. Put these in 1. Sorry. Put these in 1. 1 is this equation. Put these in 1. What do you get? If you put those in 1, 0, 0. X is equal to 6. X plus y0 is at 0 equals 6. So we get X is equal to, we get X equals 6. So this is a point on that plane. 6, 6, 0, 0. 6, 0, 0. 6, 0, 0 is a point on this plane, meaning it satisfies this equation. Now, can somebody tell me where would this cross the, so that is on the x-axis. Do the same for y-axis. Do the same for y-axis. On the y-axis, what is 0? On the y-axis, xy plane, Z is equal to 0, and y-axis on this plane, that is x equals 0. On the y-axis is the intersection of Z equals 0 and x equals 0. So you can just say on the y-axis, if it is y-axis, y is the only varying thing, the other two are zeros. So similarly, on the z-axis, that's easy, on the z-axis only, if you take axis, only that coordinate is varying, the other two are zeros. Z-axis is this one, x equals 0, and this one, y equals 0. On the y-axis, these two are true. What is my equation? Equation is x plus 2y plus 3z equal to 0. Now, put this in 1. 1 gives me x is equal to, if you put z equals 0 and z equals 0 and x is equal to 0, 1 gives me x0, z0. 2z equals, not 0 here, 6. 6 is what is. I'm trying to plot this now. So that will give me y is equal to, 2y is equal to 6. Y is equal to 3. So it goes through the point 0, y coordinate, 3 z coordinates. So if you take these three numbers, it satisfies this equation. So let us say 3 is there on the y-axis. Tell me, where does it cross the z-axis? Z-axis. At what point does this plane cut the z-axis? So I have to solve z-axis and this equation. Z-axis is x is equal to 0 and y is equal to 0. Then we get 3z equals 6. Therefore, z is equal to 2. Let us say 2 is there. That is how I got same thing. Now I have 3 points satisfying this linear equation. Just join them. In the tute also, I have given, I didn't assign, but I ask you to draw some. That is the plane. This triangle is the portion in the first octant of the plane, given by this equation. Next, fourth one, what time is it? 2 minutes. Fifth one, sketch the graph of the equation x squared plus y squared plus z squared equals 1. Sketch the graph of this equation. So graph of a linear equation is a plane. So how did I draw it? I found the three places where this plane crosses the three axes. I have 3 points, then just join them to see the portion of the plane in the first octet. Now, sketch the graph of this equation. In fact, this is going to be, let us draw. X-axis is this way. X-axis come this way, not this now. Earlier it was the x-axis. Now this is the y-axis, z-axis. This is O. Let us suppose a point P satisfies this equation. Let us take O. Coordinates of O are 0, 0, 0. Let us take a point P whose coordinates are x, y, z. You need 3 numbers for a point. No. Now what is this x squared plus y squared plus z squared? That is OP squared. Distance from O to P. Squared is x1 minus x2 squared, y1 minus y2 squared, y3 minus, z1 minus x1 minus x2 squared, y1 minus y2 squared, z1 minus z2 squared. Add them up and take the square root. So when you square, you get OP squared equals x minus 0 squared, that is x squared, y minus 0 squared, y squared, z minus 0 squared, z squared. OP squared, distance between 2 points in the three-dimensional space. Two-dimensional space, you have this. So if you go to a 4-dimensional space, it will be plus another variable w squared. So OP distance is the square root of this, but we immediately see that OP squared is this. Now, what do we want? So we know if P is on this, OP squared is equal to 1. If P is on this, we are saying x squared plus y squared plus z squared is 1. OP squared is 1. OP is a distance. Therefore, OP is also plus or minus 1, but 1 because OP is a distance. Distance cannot be negative. So OP equals 1. OP is a distance. Therefore, it's greater than or minus sign is not taken. Remember, it's a quadratic square, no? So 2 numbers should be there for the answers, but we pick only 1. So distance from O to P must be equal to 1. This equation satisfied means distance from O to P is 1. In the xy plane, it's a circle. In the 3 space, it is a tennis ball. It's a sphere. It's a sphere. Let us put some shading. It's a sphere. So this equation, it is a sphere. In the plane circle. When you go to 3 dimension, it becomes a sphere. Now, I don't have to do any of this to train you to do that partial derivative problem. But this is to gain an understanding of the 3 space, which we have done before. So it's a sphere. Right now, I said I need 10 minutes, but I will come back to sketching. So next one I'm going to do is sketch VI. I want to do Z equals x squared plus y squared. Z equals x. Sketch the graph. Sketch the graph. You have a lecture at 10, so we started 10 minutes late. No? Yes. Do you have a lecture at 10? Sketch the graph. Are you all free? All VST students are not here. ඔගොල්ලෝ free නේද? ඔව්. දාන්නකො direct message එකක් ඔයාලට දෙන්න බැරි නම් උත්තරය. You free you are free from 10 to 11 නේද? අපිට අර මිස් වෙලා තියෙන හන්ද අපි කරමුද? Okay. මට විනාඩි 10කයි උත්තරේ ගන්න බෑ. අපි අහමු.
MTT department එකට නම් නැහැ 10. MTT department එකට නම් නැහැ 10 11.
MTT ඉන්නවද materials අය මෙතන ඉන්නවද?
ඔව්.
මේක මම අනිත් දවසේ අඳින්නම්. This is a revolution parabolide. ලස්සන එකක්. ඒක ලස්සනට කරන්න ඕනේ. How much time I have? 6 minutes. I will teach you how to do the partial derivatives. මේක මේ කාටවත් කියන්නේ එපා මම මෙහෙම කියලා දුන්නා කියලා. හරිද? ඔන්න to do the tutorial problem. Partial derivatives. මෙහෙමයි කරන්නේ. Take a function of two variables. හරිද? ඒ ටියුටර් එකට දීලා තියෙන ඒවා කරන්න පුළුවන් වෙන්නයි මේක කරන්නේ. fxy fourth problem. Suppose fxy is given by අපි කියමු 2x squared plus 3y squared. Then now make x the only variable. You treat y as a constant. හරිද? y constant and like 5. 5 වුණා නම් මෙතන එන්නේ මොකද්ද? What do we get? 2x squared plus 75. 25. Right? So it's a function of x only. The derivative, then take, or x is the only variable. X is the only variable, constant, and then x is the only variable. Derivative of that function with respect to x, we write මේ ලංකාවේ තමයි කියන්නේ ඇමරිකාවේ මේක කිව්වොත් එහෙම මිනිස්සුන්ට පණි. Da by f/4 da by x. Okay, British pronunciation. Da by f/4 da by x. This is a curly D. In United States, they just say df/dx. They are straight derivative එකටත් function of one variable වලටත් එහෙමමයි කියන්නේ. ඉතින් confusion හන්දා වෙන්න ඕනේ. Da by f/4 da by x, curly D. Meaning if you see df/dx, we are thinking of f as a function of x alone. When you see this, it means it's a function of several variables and this is the only variable. All the others are kept fixed or constant. කියන්නකො y constant කියලා හිතාගෙන මේකේ derivative එක ගන්නකො with respect to x. මොකක්ද දෙන්නේ උත්තරේ? Derivative of this with respect to x is 2 times derivative of x squared 4x. What is the derivative of 3y squared? Y is treated as a constant. Constant now, this term is a constant. Therefore, derivative is 0. This is the derivative of f with respect to x. And now tell me, what is da by f/da by y? Yeah. Now, treat can only variable is y. Treat x as a constant. Make a constant derivative. If this is a constant treated as a constant, derivative is 0. Derivative of this, y is the variable. Derivative of y squared with respect to y. That is 2y. So you get 6y. Okay, two partial derivatives have been found. These are called partial derivative. Partial derivative with respect to x. Partial derivative with respect to y. Next example. Here we are. 58. Second example. Let f of xy be xy times 2x plus 3y cubed. Find r by f over r by x. So x is the only variable. X is my only variable. Y treated constant. Y constant now. X times this. Y constant. So you have to use the product rule. Y is a constant. No? So we keep y outside. X times that. Derivative. X times derivative of this. Derivative of this is, it's a cubed. 2x plus 3y squared, power rule, times the derivative of the function inside. With respect to x now, y is a constant. Derivative of this with respect to x is 2 times 2 plus y I took out now, y constant. Constant times the derivative of the function. Derivative of this, that is 1 times the, or you can say the second function, which is 2x plus 3y cubed times derivative of x. Product rule. If you can write that. So similarly, you can find r by f over r by y. Now, y is the only variable, x is constant. So keep x outside, constant times derivative of the function. This times derivative of that. Y times derivative of, that is 2x plus 3y squared times derivative of this. X is constant, derivative 0. Derivative of this one with respect to y is 3. Product rule. Y times derivative of that plus that times derivative of y with respect to y. Now you have to treat those formulas with y, with respect to y. So this 2x plus 3y fast value the cubed times derivative of y is 1. Then when you want to find da by f over da by y, you want to find the derivative. Our parent derivative තමයි two variables තියෙනවානේ. y වලින් නම් කරන්නේ අපේ අනිත් variables ඔක්කොම constant කියලා ගන්න. මෙතන නම් තව එකයිනේ තියෙන්නේ. x විතරයි variable. So x තමයි අනිත් variable එක. අපිට partial derivative of f with respect to y හොයනකොට x ව constant කියලා ගන්න. එතන මෙතන නිකන් පහ වගේ. මේකට යනකොට. මේකට එනකොට y ව constant කියලා ගන්න. මේ දෙකම නිකන් පහ කියලා හිතාගෙන තිබ්බනම් එන ෆන්ක්ෂන් එක තියෙන්නේ. ඒක ඩිෆරන්ෂিয়েට් කරන විදිහට තමයි මේක ඩිෆරන්ෂিয়েට් කරන්නේ. දැන් මෙතන මේකට එනවා නම් y is treated as a constant. එහෙනම් constant times a function. This constant can be written outside times the derivative of the function. This one times derivative of that. The x times derivative of this ගන්නකොට with respect to x 2x plus 3y squared power එකක්නේ times the derivative of the function inside chain rule. What is the derivative of the function inside with respect to x? 2x නේ තියෙන්නේ 2. Derivative of y is 0 because y is treated as a constant. Plus that times derivative of x. ඒක times derivative of x කියන්නේ 1. මෙතෙන්දි කරනකොට y තමයි variable එක. X is treated as a constant. So x treat කරනවා constant එකක් හැටියට කරලා. So you keep x outside, constant times derivative of this with respect to y. Y තමයි variable එක. So dy y වල derivative එක with respect to y is 1. So y times derivative of this. බලන්න. Y times what is the derivative of this? 3 this 2 times derivative of the function inside. It's like 2x plus something constant. For the y, for y, yeah. For y, no? So 2x is a constant. It's like 5 plus 3y. I want the derivative of that with respect to y. May y is the variable. May actually get derivative of the y with respect to y. X constant. It's all derivative of bindu y 2x plus derivative of this is 3. So y times this one times derivative of that. Our partner product rule plus that times derivative of this. Y derivative of y with respect to y is 1. Product rule. Quotient rule හැම එකක්ම දාන්න පුළුවන්. එහෙනම් you submit only the only problem 1 and 2 අද කරන්නකො. අනිත් එක මේ අපි මේක Thursday, sorry, Friday we shall finish it. එහෙම කරමු. Friday පුළුවන් ගිහිල්ලා yes. Oh my God. Oh, nail. Yes. So we shall stop there. You have another lecture now. Friday, can we do it? අපිට 7 ඉඳන් 8 වෙනකම් කරන්න පුළුවන්ද? Fridays instead of 8 to 9. I have a meeting at 9 in Colombo. මම ඒකන්දම කොළඹ ගිහිල්ලා උදේ පාන්දර මේක කරලා මීටින් එකට යන්න ඉන්නේ. Can we එහෙම පුළුවන්ද? නැත්නම් 7:30 පටන් ගමුද? Students 7:30 to 8:30 කරමු. පැය භාගයක් කලින් එන්න පුළුවන් නේ Friday?
පුළුවන් සර්.
Okay, so we shall start අනේ ඔක්කොටම දාන්න මම කියන්න මිස් අනුරිටත් she gave resignation එයත් ගියා. Yeah, Pereda, the EA in the if not, she will help us with the sticker. Course, අවශ්‍ය tudes ටිකයි assignments ටිකයි මේ දෙන්න. ඔයාලම assignment එක හෙට දාපුවාම හැබැයි Friday 12න් ඉස්සෙල්ලා තියෙන. ඒකට මොනවාරි ප්‍රශ්නයක් තියෙනවා මගෙන් අහන්නකො. හෙටම කරලා දාන්න. හෙට රැයට කරන්න. පැය 3ක් දාන්න. හොඳටම පුළුවන්. රැයට lectures ඉවරනයින් පස්සේ 9ට upload කරන්න පුළුවන් නම් free නම් 9ටම කරලා දාන්න. 9 ඉඳන් මේ 11 විතරනකොට ඉවර වෙනවා. ඒකේ තියෙන ඔක්කොම notes මේව බලාගෙන කරන්න පුළුවන් නේ. But don't copy, හදිස්සියට කියලා copy කරන්න එපා. copy කරනත් අහු වෙනවා නිකම්ම. ඔය පොඩි දේවල් තියෙනවා copy කරනකොට ළමයි දන්නේ නැතුව copy කරනවා. ඒක වැරද්ද. සමහර වැරදි තියෙනවා ඒවා ළමයි දෙන්නේ කරන්න බෑ. ඉතින් copy කරන එක අමාරුයි. මේ හරියට කරනවට වඩා. මට ඒක නිකන් පැය 3ක් දීදී වෙලා කරන්න කියලා දාන්න තිබ්බනේ මම එහෙම කරේ නෑ. I just want you to learn the material. ඒකයි. So හෙට paper එකට questions කීයක් තියෙනවද? 5ක් දෙන්නේ. Just 5 questions. ඔය නිකන් මේවා ටික ඔක්කොම cover වෙන්න දෙන්නේ. Linear algebra part එක. Okay? ඉතින් මේ lazy. ඒ කියන්නේ basic techniques ටික ගෙනියන දිනද කියලා බලනවා විතරයි. මම දන්නවා හෙට වැඩ කරන දවසක් ඒ වුණාට ඔබට කරන්න පැය දෙකකට මේ පැය දෙකකින් කරන්න පුළුවන් හොඳ ළමයෙක්. එතකොට මේ හොඳ නැති ළමයෙක් ගත්තොත් ඉතින් පැය 3කින් කරයිනේ. හරි. ඉන්වර්ස් එක හොයන ඒවා තියෙනවා. මේ eigen values eigen vectors හොයන ඒවා තියෙනවා. row reduction තියෙනවා. ඒ අර පාලන කරපු ටික. හරි. ලොකු දෙයක් මේවා කරන්න යන්නේ නැහැ. තේරුම් ගත්තද කියලා බලන්න විතරයි. හරි. එක ගානක් ඉතින් චුට්ටක් හෙට මෙට දාලා තියෙන්නේ. කියන්නේ මොකද්ද? අහන්න.
සර් particular මේ function එකේදී e to the power alpha x ආවේ නැත්නම් එතන කොහොමද සර් හොයන්නේ?
දැන් particular function එක හොයනකොට අර මෙන්න මේවානේ අපි කරපු ඒවා. එහා පැත්තේ e to the power alpha x ආවොත් පුළුවන්. ඒ වගේම එහා පැත්තේ මේ මොකක් හරි polynomial නිකන් x e to the alpha x වගේ තිබ්බත් පුළුවන් නේද? මේ වෙලාවටනේ. ඔව්
සර්.
9ටද පේපර් එක දාන්නේ සර්. හෙට 9ට දාන්නේ. 9ට දාන්නේ අනිද්දා 12ට කියලා තිබ්බේ මම අනිද්දා ඔයගොල්ලන්ව හම්බ වෙනවත් නේද? හෙට රෑම් සබ්මිට් කරන්න කිව්වා නම් හරිනේ නෑ. අනිද්දා පැයකට 7:30 to 8:30 එන්න partial derivatives ටික කරලා ඉවර කරනවා. මොන හරි පේපර් එකේ ප්‍රශ්නයක් තියෙනවා නම් කියන්නකෝ. අපි නැත්තම් මෙහෙම කරමුද? හෙට 9ට හෙට නෙමෙයි සිකුරාදා 9ට දාලා සෙනසුරාදා 12ට සබ්මිට් කරන්න දාමු. එහෙම හොඳද? මම ඒ අතරතුර ටියුටෝරියල් එකේ වන්නම්. එහෙම හොඳයි නේද? ඉතින් ඔයගොල්ලන්ට මේ සැටර්ඩේ මෝර්නිං එක තියෙනවානේ කොහොම වුණත් කරන්න. හරි එහෙනම් ඔක අනිත් ළමයින්ටත් කියන්න. ෆ්‍රයිඩේ 9ට අද ටියුට් එකේ වන්නම්. ටියුට් එකේ වන්න විදියක් නැහැ තව කරන්න නැතුව මෙතන. ඒකයි. කොහමද ඔයගොල්ලන්ට කැමති අහලා බෑ නේද? කියපු විදිහටම කරනවාද? හෙට 9ට දාලා ෆ්‍රයිඩේ කමන්නේ නැද්ද? ඉවරක් කරගන්නවාද එහෙමම? ඒතර වීකෙන්ඩ් එක තියෙනවනේ ඔයගොල්ලන්ට.
Okay, sir.
Okay, so then I'll upload it at 9, tomorrow 9 and submit it exam නේ ඉතින් ඔබ පැය 3 දෙන එක මේක තියෙනවනේ ඕනපදම් වෙලාව. හරි. හෙට 9ට upload කරනවා. Then submit it by Friday noon time. අපි 7:30 හම්බ වෙමු. 7:30 හම්බ වෙමු. අර ළමයා අහපු මේ question එක e to the alpha x නැතුව වෙන මොනවා හරි තිබ්බොත් කොහොමද කරන්නේ? e to the alpha x තිබ්බොත් දන්නවා. 1 over fd e to the alpha x. ඒ ෆෝමියුලා එක දානවා. 1 over f alpha e to the alpha x. ෆෝමියුලා එක දාලා කරත හැකි f alpha බිඳුව නෙමෙයි නා. f alpha බිඳුව නම් හරි මෙහෙම හරිනවා. f alpha equal to 0 or something like f alpha equal to 0 or e to the alpha x times u. ඒ જાතියවත් කරන්න පුළුවන්. where u is a function of x. Function of x now. u is a function of x now. You can මෙන්න මේක වගේ. e to the alpha x තව එකකින් වැඩි වෙලා. හරිද? දැන් alpha කියන එක බිඳුව නම් එහෙම මේ ටර්ම් එක නෑ. ඒතකොට u විතරයි තියෙන්නේ. function of x නම් එන්නේ අපි දානවා මේ දෙකෙන් ඕන එකක් වෙලා තිබ්බොත් particular solution එක හොයන්න කොහොමද? 1 over f of d e to the alpha x times u. Function of x. ux. u of x. එහෙම දැම්මත් කමන්නේ. මේක සමානයි කියන්නේ මොකකටද? e to the alpha x ඉදමදී. e to the alpha x 1 over f d plus alpha. u කියන ෆෝමියුලා. මේක දාලා තමයි කරන්නේ. ඒතකොට ඔයාලට particular මේක දාලා හොයන්න. ඒතකොට දැන් මෙතෙන්ට alpha නැති එකක් තියෙනවා නම් අපි alpha බිඳුව කියලා ගත්තාම ඉතින් එකයට මේක දාන්න ඕනෙත් නැහැ. if alpha is 0. F alpha 0 වුණත් if it is of the form e to the alpha x times a function of x like here, or something like x squared e to the alpha x, or a combination of those, or a polynomial at poly in x times e to the alpha x. ඒ જાතිය ගණන් හදන්න පුළුවන්. මෙහෙම આવොත් කියන්නේ u මේක තමයි u හැටියට ගන්න එතකොට u e to the alpha x times u. ඒ වගේ එකක් තියෙනවා නම් කරන්නේ කොහොමද? මේ ෆෝමියුලා එක දාන්න. e to the alpha x goes out 1 over fd plus alpha u. මේක හදන්නේ අර power series එක දාලා. power series එකක් මෙහෙම එක යට මොකක් හරි එක යට හදා ගන්නවා 1 minus x විදියට. x වලින් නෙමෙයි එන්නේ ඒක හදා ගන්න. ඒතකොට d වලින් f of d හදා ගන්නවා මෙහෙම. හදලා මේක දානවා 1 plus x plus x squared plus dot dot dot. ඕක හරියන්නේ නම් මේ වෙලාවට නමුත් මේක ඔපරේට් එකකින් ආක් කරලත් කරන්න පුළුවන්. ඒක කරාදී තමයි අර මේ ඉන්නේ අපි ගත්තොත් එහෙම d of x තිබ්බොත් මෙතන එනවානේ x වෙනුවට d නේ එන්නේ. d දාලා ගත්තොත් එහෙම අපි හිතමු 1 minus d තිබ්බා කියලා. එතකොට 1 plus d plus so d squared. Now d of x කිව්වොත් 1යි. d squared x කියන්නේ බිඳුවයි. දෙපාරක් අවසන්. ඒකෙන් තමයි අනිත් මේ particular solutions හොයන්නේ e to the alpha x තිබ්බේ නැත්තම්. ඒතර අපි කරන්න දාන්නේ මොන වගේ ඒවද? දැන් මේ වගේ එකක් කරන්න පුළුවන්. මෙන්න මේක මම කියන්නම් ටිකක්. y double dash plus y dash plus y equals e to the 5x. මේක හදන්න පුළුවන් ඔයගොල්ලන්ට. ඊට පස්සේ 3y double dash plus 5y dash minus y equal to අපි දාමු x squared කියලා polynomial එකක් දාන්න හැදුවා. මෙතෙන්ද e to the alpha x මේ වගේ එකක් කරන්නත් පුළුවන්. මෙතනට කරන්න ඕනේ අර එක යට කැලල දාලා තමයි මේක කරන්න ඕනේ. try කරලා බලන්නකෝ. බලලි ඉවරලා මට කියන්න. 2 3 අපි හිතමු 4y double dash plus 4y dash plus y double dash equals then මෙහෙම x cubed e to the 2x. මේ ගාන හදන්නත් පුළුවන්. මේවා combination එකක් දැම්මත් පුළුවන් නේ. this plus මේක plus මේක කියලා තිබ්බනම් ඒ පැත්තේ ඒත් පුළුවන්. එතකොට polynomials එතකොට කරන්න පුළුවන් ඒව තමයි equals a polynomial polynomial equals e to the alpha x type. ඊළඟට polynomial times e to the alpha x. ඕක තමයි කරන්න පුළුවන් જાති තුන. තව ඉතින් මේ පැත්තේ sin ආවොත් කරන්න එහෙම තියෙනවා සූත්‍ර. නමුත් ඔක්කොම ටික අපි ඉගෙනුවේ නැහැ. just the basic ඒවා ටික තමයි මේ කරලා තියෙන්නේ. තේරුණාද ඔයාලට? මේ ප්‍රශ්නේ අහපු ස්ටුඩන්ට්
Sir, 1 over 1 minus x equal 1 plus x එකත් එක්ක කොහොමද sir?
ඒක නම් අපි මේ අර ශ්‍රේණි කරනකොට තමයි කරේ මෙහෙමයි. It's a geometric series නේද? මේක කියන්නකො මේකේ උත්තරේ මොකද්ද? 1 plus x squared plus ඔහොම plus x to the n minus 1. අර O level තිබ්බේ geometric series කියලා a times ar squared ar cubed ar to the n minus 1 කියපු එක තමයි මේ a කියන්නේ 1යි කියලායි r කියලා එක x වලින් replace කරලා තියෙන්නේ. මේක සමානයි මතකද 1 minus a times අර එතන සූත්‍රයක් තිබුණාද a minus 1 to the r එන් මම කරා මේක ගිය පාර ඒ වුණාට කමන්නේ නැහැ. මේක තමයි a plus ar plus මතකද මෙහෙම එකක් කරනවා ඔයගොල්ලන්ට a to the r n minus 1 කියන්නේ සමානයි මේක. ඕකේ r එක නෙමෙයි නම් තමයි මේක පාවිච්චි කරන්න පුළුවන්. මේක කමන්නේ. ඔව්. මේක එතකොට ගත්තාම ඉන්නේ 1 minus x to the n. a කියන්නේ 1යිනේ over 1 minus x. හරි absolute x එකට අඩු නම් x to the n goes to 0 as n goes to infinity. දැන් මම ලියපු එක infinite series එකනේ මෙතනින් නවත්තන්නේ නැහැ. මේක plus dot 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 දානවා. infinite series එක sum එක හොයන්නේ ඒකේ partial sums අරගෙන ඒකේ limit එක බලනවානේ n goes to infinity වලට. මේ කැලේ infinity n infinity යනකොට මේක බිඳුවට යන්නේ මෙහෙම දානවා. ඒක හන්ද තමයි 1 plus x squared plus dot 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 කියලා දැම්මහම this is equal to 1 over 1 minus x for absolute x less than 1 කියලා කිව්වේ. එතකොට මේ පැත්ත දැක්කහම මෙහෙම ලියා ගන්න පුළුවන් වෙන එක ගොඩක් වැදගත්. මේක හරිද කියලා වෙන විදිහකට ඔප්පු ගන්න ඕනේ නැහැ. ඕනනම් මම හරහට වැඩි කරාම මේක වැඩි කරාම අනිත් පැත්ත ඔක්කොම කැපිලා ගිහිල්ලා මේ දෙක විතරයි ඉතුරු වෙන්නේ. අවබෝධයක් ආවද? එතකොට දැන් අපි කිව්වේ මේක තිබ්බත් නැතත් අපිට තිබ්බොත් එහෙම 1 over ඒතර මේක මතක තියාගන්නම. හරි ජියොමෙට්‍රික් සීරීස් එක කන්වර්ජ් වෙන්නේ අර වෙලාවට කියන එක තමයි ඔය. දැන් මේක තිබුණා නම් 1 over d squared plus 3d plus 2 කියලා තිබ්බා කියමු. 2 වරක් මෙතන මොකක් හරි තියෙනවා. අපි දාමු මේ x cubed කියලා x cubed i දාමුකෝ 5x කියලා තියෙනවා. දැන් මේක කොහොමද කරන්නේ? ආපෝ කැත වෙන ගණන් දාලා තියෙනවා. මේක -5x කරනවා. ඔක තියෙනවා. Particular solution if this it is the Tamil speaking students I use some Sinhala terms because the question was asked in Sinhala. Tamil speaking students, do you want me to explain this further? This is the O-level geometric series result that applied to this geometric series. A equals 1, R equals x. In this, A is 1, so A is not there. 1 minus x to the power n over 1 minus x. So if absolute value of x less than 1, meaning x is between -1 and +1. If x is between -1 and +1, x to the power n, like half to the power n. If you take half to the power n, it's a number between this. Half to the power n, as n goes to infinity, these numbers go to 0. As n goes to infinity. From this, to get this infinite series, what we do is, we let n go to infinity in this. This is an infinite series. Its sum is the limit of the first n terms as n goes to infinity. First n terms is this. This goes to 0 as n goes to infinity. Therefore, this entire thing goes to 1 over 1 minus x as n goes to infinity. So we get this result. It's good to keep this as a result that you need whenever needed. So 1 over 1 minus x. If you see that, that is the expansion. Now, if you have something like this, how do you do this? It is of the form, it is this form. Particular solution when right-hand side is polynomial times e to the alpha x. X cubed times this. So, this is equal to 1 over, this is equal to e to the minus 5x if this is there, we use this result. It's x cubed times e to the alpha x. I have written it the other way because I wanted to factor this out. So it's better to have that written there, but nothing. You can use it either way. Equals e to the alpha x 1 over d plus alpha. So e to the alpha x. So what is the formula? 1 over fd e to the alpha x u, where u is a function of x, is e to the alpha x 1 over f d plus alpha times u. Apply it to this. U. This is u. This is e to the alpha x. Alpha is minus 5. How do you apply this result? E to the alpha x taken out, minus 5 makes d is replaced by d plus alpha. So d minus 5. So instead of d, I have to write d minus 5 squared plus 3 d minus 5 plus 2 x cubed. Then make a whole ahead. E to the minus 5x 1 over d squared 10 minus 10d plus 25 3d plus 3d minus 15 plus 2 x cubed. E to the minus 5x 1 over d squared minus 10d plus 3d. Plus 3d is minus 7d. Then 25 minus 15. 10 plus 2 plus 12 x cubed. Then make a prashna. How do we do that? We write this as e to the minus 5x 1 over, I have to make a 1. I have to make it look like 1 minus x. 12 is there, factor 12 out. D squared minus 7d over 12. But since you ask, it's my duty to and then come here. Now it is like 1 plus x. 1 minus x. E to the minus 5x 1 over 1 plus 1 minus x formula. 1 minus x here 1 plus x d squared minus 7d over d squared minus 7d over 12 x cubed. Then make a expand 1 minus x expand you get e to the minus 5x over 12. Make expand 1 minus x minus d squared minus 7d over 12. Plus minus x squared. 1 plus x squared. X squared can d squared minus 7d over 12 squared. Api make x squared lazy x cubed. Because d cubed, if it is x cubed, dx is 3x squared. d2x is d2. d squared x is 6x. d3 is 6 and d4 only would make it 0. If you make an expansion again, d4 එකක් මෙතන එනවා. තව එනවනේ ඉතින් 4 යනකම් ලියන්න වෙනවා. ඉතින් ගොඩක් වැඩි. අපි මේක x කියලා කියමුවා x squared කිව්වා නම් මෙතනින් නවත්තත හැකියි. කමන්නේ ක්‍රමේනේ ඕනේ. minus b squared minus 7d over 12 cubed plus කියලා ඒව වැඩන්නේ x cubed make expand කරලා ලියුවා 1 plus x x is minus this no minus then this squared cube minus වෙනවනේ minus දැන් ඊළඟ එකට ගියොත් එහෙම after taking the fourth power d4 එකක් එනවාමයි අඩුම. එතකොට මේක ඩෙරිවේටිව් එක වැඩක් වෙන්නේ නැහැ බිඳුවයි. දැන් මේවා හොයන්න ඕනේ. x cubed මේක දානකොට dx cubed is 3x squared. d squared x cubed is 6x. මේක ඉතින් වර්ග කරලා ඉවර වෙලා d වල 4 එක වැඩක් නැහැ. okay twice the product of these two ගන්නකොට d cubed එකක් එනවා. ඊට පස්සේ d squared එකක් එනවා. ඒව වෙනම කරන්න ඕනේ. මේක cube කරනකොට එනවනේ d වල 6 එකක් එනවා, d වල 5, d වල 4, ඉතින් d3 ඉඳලා මේ d3 ට වැඩි ඒවා අහක් කරනවා. d to the power 3 වලට වැඩි ඒවා අහක් කරලා මේ හොයලා ගන්න ඕනේ. ටිකක් ක්‍රමයේ කිව්වේ බය වෙන්න නෙමෙයි. Okay, so those are the types you can do. A polynomial is බොහොම ලේසි එකක් දෙන්නේ. ඒක නෙමෙයි. You are trying to understand the method. That's the important thing. ඒක තමයි මම කියන්නේ. equals a polynomial දුන්නොත් පුළුවන් මේක පාවිච්චි කරන්න. ඒක ලොකු එකකට නෙමෙයි අපි එකක් කරලා පෙන්නවනේ. ඒක ආයෙසර කරන් බලන්න. polynomial. e to the alpha x type තිබ්බොත් ඒකත් පුළුවන්. polynomial times e to the alpha x ඔය දැන් කරන්න ගියා වගේ එකක් ආවොත් ඒක විනාශයි නේද? නමුත් ක්‍රමේ ගොඩක් මේ ගොඩක් මේ ක්‍රමේ ගැන ගොඩක් දේවල් කියන්න පුළුවන් නෑ ඒ වගේ එකක් නම් මේ කරන්නේ. ටියුටර් එකට වල අසයින්මන්ට් එකකට මේ වගේ කැතට මේව වෙන එකක් දෙන්නේ නෑ. හරිද?
සර් එතකොට ආන්සර් එක D වලින් තිබ්බා.
D වලින් තියන්න බෑ. ආන්සර් එක දැන් D දැන් මෙතන බලන්නකො. අපි මේ ටර්ම් එක මේකට දාලා බලමු. මම ඒක කරලා පෙන්නන්නම්කො. පළවෙනි එක මොකක්ද දෙන්නේ? x cube නේ. මේක දාමු මෙතෙන්ට. මොකක්ද දෙන්නේ? d squared minus 7d over 12 කියලා මෙතනින් තියෙන මොකක්ද? මේ හැම එකකටම x cube තියෙනවා. x cube කොහොම නේද තියෙන්නේ?
ඔව් සර්.
ඔව් මේක ලියන්න කොහොමද? මේක සුළු කරන්න හැටි බලමු. 1 over 12 එළියට ගන්නවා. මේවා derivatives නෙමෙයි. එතකොට ඉතුරු වෙන එක ලියන්න පුළුවන් මොකද්ද? d squared x cubed minus 7d x cubed. ඔබ ලියන්න පුළුවන් නේද? හරිද? මේක මේකට මේක මේකට. අද මේක කියන්නකො. dx cubed කියන්නේ කීයද? dx cubed කියන්නේ ඒකේ තේරුම මොකද්ද? derivative of x cubed. d කියන්නේ d over dx කියන ඔපරේටර් එකනේ. d apply කරනවා කියන්නේ මොකකට හරි derivative එක ගන්න කියනවා. එතකොට x ගානේ derivative එක මොකද්ද? d of x cubed is or 3x මේක ඇල්ල වෙන්නේ 3x squared. තේරුණා නේද? මේක කියන්නකො. d of x cubed කියන්නේ 3x squared. d squared x cubed කියන්නේ තව පැරයක් ගන්න කියලා නේද? ඒක දෙන්නේ මොකද්ද?
6x.
6x. මේක ඇල්ල 6x. මෙතන දැම්මම වෙන්නේ මොකද්ද? 6x minus here 21 x squared. තේන අසුරු කරපෑටි. d වලින් නෙමෙයි උත්තරේ තියන්නේ. ඒක derivatives අරගෙන. ඔය ASCII 1 over d කියලා තිබ්බොත් එහෙම 1 over dx squared තිබ්බොත් මේ කියන්නේ මොකද්ද? 1 over d කියන්නේ integration. Inverse operator එකනේ d වල derivative එකේ inverse operation එක කියන්නේ integration. Integral x squared dx. ඒතර d of මේක තිබ්බොත් එහෙනම් එතකොට උත්තරේ එන්නේ x cubed over 3. plus c ඕනේ මොකද particular integrals හොයද්දී කයිනේ ඕනේ. තිබ්බහම තව තියෙනවද plus
ඉස්සරහ තියෙන e to the power minus 5x එකත්
මේ උත්තරේට එකත් minus 5x over 12 මේ ටික ඔක්කොම කරලා එන උත්තරේ වැඩි කරන්න ඕනේ. හරි? මේ ආත්මෙදි කරන්න ඕනේ මම හිතන්නේ ඒක. මොකද x cube දාපුවාන්ද මේක expansion එක කොච්චරක් දුරට ලියන්න ඕනේද? Expansion should be written to make sure that all the terms are d to the 4 or higher. What is d to the power 4x cubed? මොකද්ද මේකට උත්තරේ කියන්න බලන්න.
0.
0. Because d3x cubed මොකද වුනේ? d2 x cubed is 6x. d3 is 6. d to the power 4, derivative of 6 is 0. So d to the power 5 එකත් or n for n bigger than or equal to 4. සමානයි වෙන බිඳුවනේ. දැන් ඒක හදලා අර පද ටික ඔක්කොම අහක් කරන්න පුළුවන්. මෙතන නම් තව පදයක් කියනවා d to the power ඊළඟ එකේ තව යනවා ගොඩක්. ඒක කැත ළඟින් ලේසිම විදිය තමයි මේක නිකන් වර්ගය වගේ දාලා ෂේප් කරන්නේ. නමුත් මෙතෙන් දෙකනේ කියලා දුන්නේ කමන්නේ නේද? කන්ෆියුස් වුණාද? තේරුණාද?
තේරුණා සර්.
මේක හදන්න යන්නේ මම හදන්න එකක් දෙන්න. මේක හදන්න පුළුවන් කියලා බලන්න. x times e to the 2x. මේක කරන්න පුළුවන් කියලා බලන්නකෝ. මේක සමානයි කියලා ලියන්න මොකක් කියලාද? e to the 2x එළියට ගන්න. 1 over d plus 2 නේ. d plus alpha නේ. squared plus d plus alpha plus 2 then the xl. දැන් මේක හදාගන්න බලන්න. අර කලින් කිව්ව විදිහට. එතකොට ඇත්තටම dx කියන්නේ කොච්චරද? dx කියන්නේ 1යි. d2x කියන්නේ බිඳුවයි. එතකොට ලේසි මේක කරලන්න පුළුවන්ද කියලා බලන්න. ඔන්න තව චුට්ටක් මේවා කරමු x squared දාමු. dx squared කියන්නේ කීයද? 2x. d2x squared කියන්නේ 2. d3 d3 terms එන්න පටන් ගත්ත වෙලාවෙ ඉඳලා මේක කරලා බලන්නකෝ. අර කියපු විදිහට ඉවර වෙන්නම කරලා බලන්න. ඕකේ? මට අනිද්දාස් කියන්න. හරි මෙසේජ් එකක් දාන්න හරි. You not only you the others also who are there.
සර් අසයින්මන්ට් එක සිකුරාදා නිසා හම්බෙන්නේ.
නෑ අසයින්මන්ට් එක දැන් අපි අන්තිමට ඩිසයිඩ් කරේ හෙට 9ට කියපු විදිහට දීලා සිකුරාදා 12 වෙනකොට සබ්මිට් කරන්න ඕනේ කියලා.
සර් කට්ටිය කිව්වා මේ සිකුරාදා කරනවා නම් ලේසි කියලා.
ඉතින් මම අහක් වෙලා කිව්වේ. ඕකේ එහෙනම් සිකුරාදා කරමු මම අද ටියුට් එකේ වන්නම් එහෙනම්.
හරි සර් thank you sir.
එහෙනම් සිකුරාදා 9ට why don't you put it දාන්නකො මේ ඔයගලගේ තියෙනවනේ group එක.
සර් මම ඒක කියන්න.
කියන්න ඔක්කොටම කියන්න.
හරි සර්.
එතකොට මේ සිකුරාදා 9ට දීලා ඒක කමක් නැහැ. එතකොට මම මොකද සිකුරාදා උදේ 7:00 8:00 කරනවානේ ලෙක්චර් එක. There is a lecture from 7:30 to 8:30, yeah, not from 8 to 9. Because I have a meeting in Colombo. මම කොළඹ ගිහින් තමයි කරන්නේ 7:00 ඉඳන් 7:00ට 8ට නෙමෙයි. 8 වෙනකන් එහෙම ඉන්න එපා. හරි. එතකොට මේ අප්ලෝඩ් කරන්නේ අසයින්මන්ට් එක Friday 9ට.
Friday සබ්මිට් කරන්න තියෙන කවද්ද Friday ද?
නෑ Friday 9ට දැම්මහම Saturday 12 වෙනකොට. අනේ Saturday ඔය මේ Saturday උදේ පටන් ගත්තත් ඕක පැය දෙකෙන් තුනෙන් ඉවර කරන්න පුළුවන් වැඩිම. විභාගයේ මිඩ් සෙමෙස්ටර් එකට ආවා වගේ පැය දෙකෙන් වගේ ඉවර කරගන්න පුළුවන් එකක් තමයි දෙන්නේ හොඳ ළමයින්ට. linear algebra විතරයි ඕනනම් පොඩ්ඩක් උඩින් බලා ගන්න නෝට් එක. ඔයාලා ළඟ තියෙනවනේ ඔක්කොම ඕපන් බුක් වගේ තමයි යන්නේ. ඕකේ හරි දෙන්න. එන තමන හරි තියෙනවද අහන්න? ඕකේ. අපි නාත් වෙනවා හරිද?
Thank you sir.
Okay, you are welcome. You're welcome. Bye.
Thank you, sir.
You're welcome.
Thank you, sir.
You're welcome.